Now I want to advance a bit or go out of the question and look at the area of the same triangle, but now using a different method. And this method we want to use, we are going to use Hero's formula to get the area of the triangle. So having known the three sides of the triangle, first of all, in Hero's formula, area is given by the square root of the semi-perimeter multiplied by S, the semi-perimeter, minus side A, multiplied by the semi-perimeter minus side B, multiplied by the semi-perimeter minus side C, like that. And the semi-perimeter is given by a half multiplied by the value of A plus B plus C, like that. So S in this case will be given by a half multiplied by 18 plus, into brackets, 14 plus 9.14, like that. Therefore, S is equals to, when you calculate, evaluate that, S will be equal to 20.57. So after getting S to be equal to 20.57, we come back to our formula and say now area is equals to the square root of 20.57 multiplied by 20.57 minus 18, 20.57 minus 18 multiplied by 20.57 minus 14 multiplied by 20.57 minus 9.14, like that. So area will be equal to the square root of 20.57 multiplied by 20.57 minus 18 gives you 2.57 multiplied by 20.57 minus 14 gives you 6.57, and 20.57 minus 9.14 gives you 11.43. So all this under the square root sign. So use your calculator to multiply all this. You get area to be equal to the square root, area to be equal to the square root of 3,969.90. I've rounded it off correct to 2 decimal places, and when you get the square root of this, the final answer area will be equivalent to 63.00 units, or centimeters for that matter. So here I've given it correct to 2 decimal places, 0.00 correct 2 decimal places. So it is very, very important for you to give your answer correct to the level of accuracy that the examiner requires, so that you can fully score the accuracy mark. Now let us look at the other question. It is a question on logarithms. is a question on logarithms, and in question 4, you're told to solve the logarithmic equation below. We have the log of 6x minus 2 base 10 minus 1 is equals to the log of x minus 3 base 10. So we have the log of 6x minus 2 base 10 minus 1 is equals to the log of x minus 3 base 10. Now if you look at that question, we need to rewrite or express 1 with or in logarithm form. So if we express 1 in logarithm form, we need to remember that 1 can be written as the log of 10 base 10. In index form, we normally say that 10 raised to power 1 is equals to 10. 10 raised to power 1 is equals to 10. Therefore, the log of 10 base 10, gives you 1. So if you raise 10 to power 1, you're going to get 10. Now, having known that, we shall write this as the log of 6x minus 2 base 10 minus the log of 10 base 10 to be equal to the log of x minus 3 base 10. We only subtract logs when we are dividing two numbers. Therefore, when we rewrite this in the other form, the other notation, it will be written as the log of 6x minus 2 over 10 base 10 to be equal to the log of x minus 3 base 10. And at this particular point, we can say you can take the antilog. Take the antilog on both sides. When you take the antilog on both sides, we go back to the original expression. We're going to have 6x minus 2 divided by 10 to be equal to x minus 3. And then to get rid of 10 here, multiply both sides by 10. Multiply this by 10 here and also this side by 10. So we're going to get 10 cancels out. You'll get what? You'll get 6x minus 2 is equals to, when this is multiplied by 10, you get 10x minus 3. And then you collect like terms. When you collect like terms, you're going to get subtract minus 30, 10x minus 30. Now when you collect like terms, you're going to get, or you can subtract 10 from both sides, subtract 10 from both sides, or 6 from both sides, and add 30 on both sides. So we can subtract 10 from both sides and we'll get 6x minus 10, 6x minus 10x to be equal to negative 30, add 2 on both sides, plus 2. So negative 4x will be equal to negative 28. So x alone, we divide both sides by negative 4, x will be given by negative 28 divided by negative 4, x will be given by positive 7. And that is your solution for that particular question. In the next question, more or less a similar one, we are asked to calculate or to solve for the value of x, but now the base is given as base 8. Nothing changes much. The law of logarithms still applies. You have the equation given as solve the log of x plus 5, log of x plus 5 base 8, the log of x plus 5 base 8 minus the log of x minus 3 base 8 to be equal to the log of 4 base 8, like that, to be equal to the log of 4 base 8. Now, though the base now is 8, the law of logarithm still applies here. So we don't need to worry so much about the change of base here from 10 to 8. Just need to expose you to this so that you are not tempted to rewrite or formulate your own question because we are used to base 10. So here, when we subtract logs, we rewrite it in the original form. We only subtract logs when we divide two numbers, a or b. The log of a over b is given by the log of a over b is given by the log of a minus the log of b. So I want to rewrite it in this form. So we're going to get this as the log of x plus 5 divided by the log of x plus 5 divided by x minus 3 base 8 to be equal to the log of 4 base 8, like that. So we take the antilog on both sides. We're going to get x plus 5 divided by x minus 3 to be equal to 4. When we cross multiply, we're going to get x plus 5 to be equal to 4x minus 12. And then here again, we collect like terms. When you collect like terms, you can subtract x from both sides and add 12 on both sides. So you're going to get 5 plus 12 to be equal to 4x minus x. So 4x minus x, this gives you 3x to be equal to 17. So x alone is equals to 17 over 3. X is equals to 17 over 3. We still go ahead and look at other questions on logarithms that may be set for you, and how we can solve a given question. In part 3, we are told to